Welcome to another episode of libGDX-Graph devlog. In this episode, I'll show you how to use scene color and to create a heat distortion effect for this kind of scene I've set up here. So what we have here is like a tiled wall. Here's a heat burner, and this red brownish cylinder represents basically the area that would be hot air, which would cause the distortion of the view here. So first of all, let's start off with looking at the new stuff I added to be able to create this tiled wall. So I've added new category here, shape, which allows to create this checkerboard pattern. Also, you can now change the preview model from the sphere to a rectangle. So this defines how many repeats of this checkerboard patterns are here. So I want to go with 5 by 5, and the output is a 0 or 1 in this case, and I'm multiplying it. So basically mixing the color white and black based on this output, so that whenever it's 1, it's going to be black, whenever it's 0, it's going to be white color. And for the burner, I'm using the same approach. I have an ellipse shape where I can define the size of the ellipse as well as the width of the ellipse. So width is basically how wide the ring here is. So I can increase it. I want to go with 0.5 because this looks nice for the burner, and I can modify the size of the ellipse here, x and y coordinates. Okay, and I'm using the same approach here for mixing the output. Okay, but the important here thing is that I have this heat displacement, which is assigned to this cylinder here in the middle of the scene, and it's using the heat displacement shader, and at the moment it's just playing a color. So what we want to do here, as I said, is to use the scene color node. So let's create it. It's provided scene color. Let's attach it. And what we want to here is the provided screen position. Okay, so let's save it, reload the scene, and suddenly the cylinder disappeared. But the thing is, it didn't disappear, it's just drawing exactly what is the pixel of the scene at the position when it's being rendered. So it's basically the cylinder is still here, it just looks exactly the same as was behind it. So it's basically like an invisibility cloak. So what you want to do here instead, when you want to do a distortion, is modify the position that we're going to be reading the scene color from. So let's maybe just start off with something very simple just to show how that it works. So I'll use the add, and I'll add the screen output, and I'll provide here 0.01. So I'll add these two and use that to read the screen color, the scene color. So if I reload, you can see that it's shifted because it's for each position on the cylinder, it's reading actually a pixel that is shifted by 0.01 in screen coordinates. Okay, so now what we want to do is have a much better looking distortion. So let's start off with figuring out the noise. So we're going to be using, once again, noise for this. So we'll have separately noise for x and y. The same way we have x and y. Instead of these, I want to use the x and y that's coming from noise. So I'm using noise 3D, and the reason for it is I want to also input time into it so that it's not static, it's going to be changing over time. So what I'll do here is have math provided time, and I will have for the point I need 3D, so I'll have value merge. So I'll provide this into Z, and I will split. I could use, for example, node position, but I'll be using screen position here. So I will pass X and Y here, and I'll be splitting X screen position here and using this 3D, this vector 3 that's coming from the screen position and time as to read the noise. So let's call this a noise point. I'll group these 3 nodes here. Noise point. And for the displacement, I'll do here, I have to provide scale. Let's go with 1. It's perfectly fine. And range. So this will define, this range will define how big of a distortion we want to have. So let's go with something really small, because this is in screen coordinates and the screen coordinates go from 0 to 1. So we can't use anything very big. So I use this small one here. And this we can have as a horizontal displacement. And we also use another noise 3D here. And I use this as well. And I use the same variables here for the other stuff. So I have X displacement, so X coordinates, so horizontal displacement and vertical displacement. The thing is that at the moment, the way, because we are using the same point here and scale and range, the output is going to be always the same on both horizontal and vertical, but we want to have a bit of mix. So what I'll do here is I'll create a constant vector 3, say 1, 1, 1. And instead of using this point, I'll just use add to modify this by this value and use this instead. That way I'll have different values for horizontal and vertical that will be varying separately and not together. That's pretty cool already. So we have, let's call this, create a group, horizontal displacement, and this is going to be our vertical displacement. So this gives us an output from between minus 0.05 and 0.05. So what we'll do here is I'll merge these two as horizontal into X, vertical into Y. And I will, instead of this fixed 0101 that I had before, I'll add the output of this vector 2 here. Okay, let's save it and take a look at the result of it. Okay, that's already cooler. We have X and Y, horizontal and vertical, being displaced separately, though it at the moment is very big. Normally you would see much smaller changes. So what we can do here is I can modify the screen position here as an input into the noise point. There's multiple ways of things I can do, but this is one of the things. So let's do math multiply here instead. And I'll multiply the screen position by some constant. Let's use 20, for example. This will define how localized the changes are going to be. So at the moment we have basically, when something is going right, almost entirety of this thing is going right. But if I reload it, we see the leaning left or right or up and down in here is more localized. So different parts of the cylinder are doing the distortion separately. So that would be pretty bad if I left it at this, because first of all we have a problem here with the edges, that there's a very stark difference here between normal and the cylinder. And second of all, I would like to add so that towards the up of the cylinder the distortions are getting smaller. because the biggest hit is over here. That's what's changing doing the distortion. But as we go up, the distortion should be getting smaller because the air is not as hot over there. So what I'll do here is I will be doing multiplication. So rather than just using the value from here, from the noise directly, I will multiply by some value first. So let's do arithmetic multiply. So, and use this as a result into the add here, remove this value. So what I want to multiply it is something that will reduce as it goes up. So I'll use here, because in cylinder the UVs are using, we can use V as a vertical one. I can create here a math value split. I'll split the UV and I'll multiply it, the value of the distortion from the noise, by the Y. So at the bottom the Y is 1 in case of cylinder, the part of the texture attribute is 1, so it's going to be the biggest one, and as it goes up it's going to be being reduced. So let's check if this worked. So we should be seeing here much smaller distortions going up. Okay, that's already cool, but we're still seeing the edge problem here. And the way I'll fix the edge is using the Framel effect. I think I touched on the Framel effect in the previous video somewhere. So what I'll do here, I have to provide a normal in world coordinates. I have to provide view direction, which is a subtraction of two things, and it's a subtraction of camera position, which is provided, not camera direction, camera position, and position attribute in world coordinates, yes. And I have to provide power. This will define how much it's affected towards the edge, which goes with 0.5. And output of this, because it's going to be 1 towards the edges, we have to do, and 0 in the middle, I have to do math subtract, and I'll use here a constant, 1 minus the output of the Framel. And once again, I will push it into the multiply so that it's going to be modifying the value of coming from the noise. So let's reload this. Okay, and then towards the edges we are seeing much smaller differences here. So you have to experiment with the power here with the Framel. Let's go with something big and see how big of an impact it has. Yeah, so the fall off is much smaller, so probably the value I had before is probably much better to what we want to see. Okay, so I've created officially I think pretty good, well-looking heat distortion that is reading from the scene, so everything that was drawn until the previous rendering pass, and it's fading into the as it goes up, and it's fading as it goes towards the edge of the cylinder that we are using it for, and I think I'm pretty satisfied with this. I hope you found this useful. Please consider subscribing and liking the video. Thanks for watching. Bye.